Hello, math fans! Welcome to Math Olympiad Academy, your gateway to advanced problem solving and mathematical reasoning. Today, we have a very interesting challenge. Can you solve this equation? The square root of 9 minus x equals 9 minus x squared? We will refer to this as equation E1. Before solving equation E1, the first step is to determine the domain of definition, that is, all real values of x, for which the equation E1 is mathematically valid. The domain of definition of equation E1 is determined by two conditions. First, the expression under the square root, 9 minus x, must be greater than or equal to 0. Second, the right-hand side, 9 minus x squared, must also be greater than or equal to 0. Let us examine the first condition. The expression under the square root, 9 minus x, must be greater than or equal to 0. This gives us the inequality 9 minus x greater than or equal to 0, which means that x is less than or equal to 9. Now, let us consider the second condition. The right-hand side of the equation, 9 minus x squared, must also be greater than or equal to 0. Solving 9 minus x squared greater than or equal to 0 gives the inequality x squared less than or equal to 9. Taking the square root, we find that x is between minus 3 and plus 3. Combining these two conditions, we see that the domain of definition of the equation, E1, is the set of all real numbers x that lie in the closed interval from minus 3 to plus 3. Now, the step 2 is how to solve the equation E1 quickly. So, let us apply a useful trick. We replace 9 with a new variable named t. So, the equation E1 becomes square root of t minus x equals t minus x squared, which we will label E2. Let us now square both sides of the equation E2. This gives us t minus x equals the square of t minus x squared, which is t squared minus 2 times t times x squared plus x to the power of 4. Now, let us consider this equation as a second-order equation with the variable t. After rewriting it correctly, the equation becomes t squared minus t times the quantity 1 plus 2x squared plus x to the power of 4 plus x equals 0. To solve this second-order equation in the variable t, we use the discriminant, delta, and first calculate its value. The discriminant delta is equal to the square of 2 times x squared plus 1 minus 4 times 1 times x to the power of 4 plus x. After developing and arranging this expression, we obtain delta equals 4x squared minus 4x plus 1, which can also be written as the square of the quantity 2x minus 1. This implies that the quadratic equation in the variable t, labeled E2, has two solutions, t1 and t2, which are given by the following formulas. t1 equals the quantity 1 plus 2x squared plus the square root of delta divided by 2, and t2 equals the quantity 1 plus 2x squared minus the square root of delta divided by 2. Since the square root of delta is the absolute value of 2x minus 1, for x greater than 1/2 the quantity 2x minus 1 is positive, so the square root of delta equals 2x minus 1. When x is less than 1/2, the quantity 2x minus 1 is negative, so the square root of delta equals minus 2x plus 1. By replacing these values into the square root of delta in t1 and t2, we obtain the following simplified expressions. t1 equals x squared minus x plus 1, and t2 equals x squared plus x. At this step, let us replace t1 and t2 by 9. This technique gives us two equations in the variable x. The first equation is t1 equals t equals 9, which gives x squared minus x plus 1 equals 9. Rearranging, we obtain x squared minus x minus 8 equals 0. the discriminant delta is 1 squared plus 4 times 1 times 8, which equals 33. This gives the roots x1 equals the quantity 1 plus the square root of 33 divided by 2, and x2 equals the quantity 1 minus the square root of 33 divided by 2. Because the first root does not belong to the domain of definition, it cannot be considered a valid solution. Only the second root, which is 1 minus the square root of 33, all divided by 2, lies within the interval from -3 to +3. Therefore, it is the only solution we accept. Now, let us move to the second equation. Here, we replace t with the value 9 in the expression for t2. This gives us the equation 9 equals x squared plus x. We rewrite this equation in standard quadratic form, which becomes x squared plus x minus 9 equals 0. To solve this quadratic equation, we calculate the discriminant. The discriminant is equal to 1 squared minus 4 times 1 times -9. This gives us 1 plus 36, which is equal to 37. Since the discriminant is positive, the equation has two real solutions. These solutions are x3 equals -1 plus the square root of 37, all divided by 2, and x4 equals -1 minus the square root of 37, all divided by 2. Now, let us check which of these values belongs to the domain of definition. The value -1 minus the square root of 37 over 2 is approximately -3.5. This number does not belong to the interval from -3 to +3, so it is rejected. The quantity -1 plus the square root of 37, all divided by 2, is approximately 2.54. This number lies inside the domain of definition, so it is accepted as a valid solution. Finally, solving the equation labeled E1 revealed 4 algebraic roots. However, most of these values fall outside the domain of definition and therefore cannot be accepted as legitimate solutions. Only 2 values satisfy both the algebraic computations and the domain constraints. The first valid value is -1 plus the square root of 37, all divided by 2. The second valid value is 1 minus the square root of 33, all divided by 2. Thus, the complete set of solutions to equation E1 is x equals 1 minus the square root of 33 divided by 2, or x equals -1 plus the square root of 37 divided by 2. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!